We're given a cuboid, which is illustrated by figure 1. I'm just going to start the question by writing down these position vectors in component form. I'm going to denote it as little a, the first one. So it will be 5, 0, 0. Then OC, which I'll call C, is going to be 0, 10, 0. And OD will be 0, 0, 20. Now we're asked about the cosine of angle CAF. So C to A to F. Now it's really difficult from the diagram to make out that angle, like or draw the angle in even, but hopefully you can visualize it. We've got the base, and then it's going up the diagonal up to F, and I could draw it in 2 dimensions a little bit more simply. So A, C, and F, and I'll be interested in these 2 vectors, A to C and A to F. Hence, I can use a dot product to find the angle in between. So what I need is OF. And to get from O to F, I could go from O to A, and then I could go, what else could I go? I could go O to A, and then I want to get, I've got O to D, so I can go up, O to D. So far, I would have gone along here, and then O to D is the same as A to E, so along to here. And then finally, I've got O to C, of course, so if I add that on, I'll get to F. And this is quite easy to add, it's just going to be 5, 10, 20. So I need to find out what AC is. And that's going to be little c minus little a. If you're not sure about that, then draw your origin in and think about it. How can you get from A to C? Well, we're going to need to go minus A to get back to here, and then plus C to get to here. So I'll end up with minus 5, 10, and 0. Whilst A to F is going to be F minus A. To be fair, I didn't call it that, did I? Let's write that in now. And so I've got 5, 10, 20, but I'm minusing the 5, so I'll get 0, 10, 20. Then I can do the dot product. So the first version of the dot product is going to be to just times their components accordingly. So I'll get 0 plus 100 plus 0, so it's going to be 100. But it's also going to be the magnitudes multiplied together, which will give me 125. Here, here I'll have 500 because it's 400 plus 100 times cos theta. Now we just need to think about how we can simplify that. So 100 is going to equal, right, let's simplify the thirds. So this 25 goes into this 5 times. So it's going to be 5 root 5. Whoops. I've just written 5 times 25. So root 25 times 5. So 5 root 5. And then I'm going to get 100 times 5 here. So it'll be 10 root 5. And the root 5 times root 5 is going to be 5. Times that by 5, 25 is going to be 250. And therefore cos theta will equal 100 over 250. I can cancel that down. 5 goes into this, so it's going to be 2/5. Okay, so that wasn't too bad, just a little bit of, writing different vectors using the dot product. And we've managed to get the angle CAF. In part B, we're told that there's a point X that lies on AC. I'm just going to get another diagram and illustrate this. So let's just put it here for now. And we're also told that Fx is perpendicular to AC. And we're asked to work out the position vector of x and the distance fx. Right, and let's think about this carefully. How do we get OX? Well, we know that somehow, okay, OX, we know we need to get onto the line AC. So it's going to be A, get onto AC, and then it's going to be some amount of the vector AC. Okay, basically, I'm writing down the equation of a line, but it's going to be like a fixed parameter that we actually need to find. So A, if you remember, was, I think it was 5, 0, 0. And then AC we calculated up here. It was minus 5, 10, 0. So I'm also going to multiply through by the t that I have to give 5 minus 5t, 10t, and 0. So that's our position vector OX. We just need to find out what t is. And we can do that by finding out what f of fx is as the vector. So I'm going to change these to vectors, in fact, because then I can use the dot product with AC and it's got to equal 0. Fx will equal, if I call this x, this thing is x, then it's going to be 5 minus 5t, 10t, 0, and I'm minusing that f, that OF that I found before. Where's it gone? 5, 10, 20. So I'm left with minus 5t, 10t minus 10, and minus 20. Then I can take the dot product, AC dotted with fx, and it's going to equal 0. So AC was minus 5, 10, 0. So I'm just multiplying the components as before, and then the 0 isn't going to contribute. And then that will equal, so I'm having to move up and down a little bit because I keep forgetting the values. I do have them on paper, but I'm just trying to illustrate it here. So that will equal root 125. Wait, what am I talking about? I don't need to do that because it's going to equal 0. Sorry. That's the whole point of this. We find the dot product, set it equal to 0, okay, because the angle is 90, and now we're ready to solve. So 25t plus 100t minus 100 is equal to 0. That means 125t is equal to 100, and t is equal to 100 over 125. 25 goes into both of these, and t is going to be 4/5. We were asked to remember to find OX, and that was here. So it's going to be 5 minus 4. It's going to be 10 times 4/5 is going to be 8, 0. So it's going to be 1, 8, 0. And we were also asked for the distance fx. So I'm going to work out the vector fx to start with. And there's no t here, so I just get minus 20. Which gives me root 420. It doesn't seem easy to simplify or anything like that, so I'm just going to leave it as this. Okay, good. Just keep going. To finish, we're asked, we're told that the line L1 passes through O and through the midpoint of the face ABFE. I think another diagram would come in useful for this. So ABFE, it's going to be the middle here. So I'm going to get a line goes through like this. And of course it does extend the other side as well. So what I really need is to work out the position vector of this. And we can see that to get to this point, I could go along A. Then I could go along, that's actually a vector, isn't it? I'm going to go along halfway from A to B, which is the same as halfway from O to C. So it's going to be half C. And then finally, I'm going to go up half of OD. So this is a half D. And maybe, what should I give this? I'll call it M. So OM, which is going to be little m, is going to be A plus a half C plus a half D. If you figure that out, I'm just writing from some paper where I did it previously now rather than going up the screen. It's going to be this plus this. Remember, C was 0, 10, 0, and D was 0, 0, 20. So if I find half of it, I get 10. And we get 5, 5, 10. Hence, L1, normally you have to get from the origin onto the line, but actually the line goes through the origin. It tells us that. And therefore we can write down the equation of the line. It's simply going to be R is equal to I kind of don't want to use a t because I used a t in a previous question. So I use lambda. You tend to use t and s or lambda and mu. So I use lambda here. We lambda 5, 5, 10. Yeah, that's good. We've got one of the lines. We're then told that L2 passes through A and through the midpoint of the edge FG. There we go. Let's try and work out that midpoint. I don't want to call it n because n's usually used for the normal, so I'll call it little p. And I'm actually interested in um, A to P because that's where the line goes through. So A to P, I'm now going to go all the way along C. I'm going to go all the way up, which is the vector D. And then I'm going to go this way, which is the opposite to A, so it's going to be minus a half A. And I can figure out what that is. This time it's going to be 0, 10, 0, plus 0, 0, 20, minus 2.5, 0, 0. And the equation of L2, well, we first need to get onto the line, so we can just go along A, get onto the line, which is going to be 5, 0, 0. And then I can add mu, lots of this 2.5, minus 2.5, 10, 20. I'm just thinking about this. I could maybe simplify these a little bit because like there's a factor of 5 here, so I could take it out. I think that might be easier. So I'm going to simplify both of them. L1 can actually be written, if I take the factor of 5 out, I'll get 5 lambda, and I could just call that something else like t. So it's actually going to be, okay, I'm going to use t. It's going to be t1, 1, 2. Much simpler. And L2, well, okay, I need to get onto the line, so this needs to stay the same. But now I can take a factor of 2.5 out and, 2.5 mu, which I can just call s. And it's going to be minus 1, 4, and 8. And again, that's just a bit easier to deal with. So I'm interested in where they intersect. And where they intersect, the x coordinates will be the same, the y coordinates will be the same, and the z coordinates will be the same. If you don't change it like I have, it will still work out. The numbers will just be a bit more awkward, and you have to divide through. So we actually see that it's guaranteed to be consistent because these two are just the same equation. Normally you try two of them and you check it into you check the third one also works, but we can see if the second one works and the third one would also work. And I can actually, because I got t and t, I can literally just say that 5 minus s must equal 4s. That means that 5 is equal to 5s and s is going to equal 1, from which we see that t must equal 4. All that's left is, I think we were asked to actually find the coordinate of intersection, so I can just put it back in, and it would make sense to put it back into the simplest one, which is going to be L1. So hold on, I can just say, yeah, so we'll be consistent. I should probably just say they will intersect. I'm just going to work out the position vector of the intersection point. So I'm going to put 4 back into here. That's what I meant. That's going to be the simplest one. It's going to be 4, 4, 8. And the coordinate follows simply as 4, 4, 8. Okay, good effort on this question.